Hey guys, thank you for joining me for another fun module of the CompTIA A course. And as you can see, today we're covering module 11, which is actually the second module in the CompTIA A course. Today's module is all about virtualization and cloud concepts. More specifically, as you guys can see here on the main topics, client-side virtualization and cloud computing concepts. Now we're saying client-side virtualization because we're specifically talking about Windows 10, Windows 8, Windows 7, something that you would install on your computer. So your personal PC is where we're going to be running virtualization. In the past, we would normally go and run this on server. And if you go run it on server, it's just virtualization. If you run it on your PC, a normal end user PC, we call this client-side virtualization. So we're going to be taking a look at how do we do that, the tools we need to go and put in place, and all the benefits and all the goodies. Then we also have cloud computing concepts. So in that topic, we're going to go and look at what is the cloud, different kinds of cloud we get, the benefits, the components, stuff like that. So now we've got all of that out of the way, guys. You know what to do. Give the video a like. That does boost this video. It does boost my channel. And quite frankly, I do this stuff for free. So that's the least you guys can go and do. If you're new to this channel, subscribe down below. And since we've got that all out of the way, let's go have some fun. Alrighty everybody, here is our first topic for this module, being virtualization. Now with regards to virtualization, we're specifically going to be talking about virtual machines and virtual containers for the most part. It's not the only things we're going to be talking about with regards to virtualization, but that's for the most part going to be the main things. Now I'm sure by now you've probably noticed that a lot of things these days are virtualized, or maybe even the cloud even. So what is virtualization when it comes to virtual machines? A virtual machine is exactly like a real computer, except it doesn't have any physical hardware. It doesn't have its own motherboard, its own CPU, RAM, hard drive. It's completely virtualized. It's running on top of what we call a host operating system. Now that's something you guys are going to be hearing a lot, is the word host operating system and guest operating system. Host operating system is the computer that's actually running these virtual machines. That is probably going to be your own personal desktop or laptop or your own physical server. So that real physical laptop, desktop or server that is running these virtual machines for you, that is hosting for them for you, that's the keyword, that is your host operating system. So in this example, let's pretend for a moment that it's Windows 10. Maybe you've got a laptop, it's running Windows 10 on that laptop. That laptop with Windows 10 is your host operating system. And on that laptop, you're going to be running some form of software that's going to allow you to go and host virtual machines, better known as VMs for short. Now that virtual machine, which is exactly like a real computer, you can go and install an operating system on each and every virtual machine that you may or may not have. That operating system that you install on that virtual machine is called a guest operating system. So if you only have one virtual machine running on your computer, that is one guest operating system. So if you've got 3 virtual machines, that's 3 guest operating systems. Now on most virtual machines, you have the ability to go and choose what operating system you want. It does not need to be the same as your host. So if your host is running Windows 10, that virtual machine could be running Windows 8, Windows 7, mind you, it doesn't even have to be Windows. It could actually be Android, Linux, it could be Apple. You can go and choose what you want to install on that virtual machine. Just bearing in mind, if it's not Microsoft, there might be some compatibility issues with regards to drivers and stuff like that. But it is stuff that you can sort out along the way. Now, to be able to run a virtual machine, you need something called a hypervisor. Now, from a Microsoft perspective, it's actually called Hyper-V, the tool we use. Ironically, they called it, Hyper-V actually stands for hypervisor. So way to go, Microsoft, for giving something a proper name. So their hypervisor is actually called hypervisor, Hyper-V for short. And there is actually a lot of other tools you can go and use, which are third party, according to Microsoft, that does the same job. So if you want to go and use Hyper-V, Microsoft's platform, on Windows 10, you're going to have to go and add it as a feature. You just need to go and turn that puppy on. Only available on Windows 10 Enterprise and Professional. It's also actually available on Windows 8 Enterprise and Professional, but let's just keep it to Windows 10 for now. It's probably going to be available on Windows 11 as well. On the server side, you need to go and add that as a role. not as a feature, as a role. All right, so let's take a bit of a deeper look into hypervisors. Each virtual machine, or VM for short, runs in a protected space. Well, yeah, if you think about it, it's a virtualized environment. It's got its own little virtual bubble, so to speak. It's its own little operating system. So if you happen to get a virus on that virtual machine, in most cases, it's going to probably be contained on that virtual machine because it's technically a computer on its own. Yes, it's being stored somewhere on your physical hard drive, but it's still kind of an operating system on its own if you think about it. So view from inside the virtual machine is the CPU and memory. So if you were to go and connect to that virtual machine, which we'll show you guys how to go and do, that is going to seem exactly like a real computer. The CPU and the memory and all that you guys are going to see is going to look exactly like a real computer's CPU and memory. Although in reality, it's actually all virtualized. The hard drive of that virtual machine is normally in a .vhd or a .vhdx format. That is if we're keeping it Microsoft. So I'm going to try and keep this Microsoft as simple as possible, but quite frankly, you can go and use a lot of other vendors. I'm going to give you guys a few examples in just a moment of what else you can go and use besides Hyper-V to go and create these virtual machines. So the hard disk drive is actually just an image file, and that is obviously going to go and occupy space on your computer's hard drive. So if you want to make a virtual machine, keep in mind you are going to be installing an operating system on that virtual hard drive, which means that's going to occupy some space. You need to know the minimum hard drive requirements for that operating system you're about to go and install. Keeping in mind you probably still need to go and install updates, drivers, possibly even software most likely. So all of that is space you need to go account for. So if the operating system, for argument's sake, needs 20 gigs of free space, you should probably go and make it 30 gigs or even 40 gigs at the very least that hard drive to give it some extra room to go and install some other nonsense if the need arises. So yeah, keep that in mind. You need to have at least 40 gigs of free space on your real hard drive. Components such as the network adapter are emulated. In other words, it's a pretend kind of network card. Keeping in mind the virtual machine has nothing of its own. Everything it has is being shared between the host and that virtual machine. This includes space on the hard drive, the RAM is being shared with the real machine, and also your network adapter. Now, with regards to network adapters, you have the ability to go and connect your virtual machines to one another. You can connect them to the host which they're being hosted on, or you can connect them to the outside world, to other virtual machines on other computers, or just other computers in general, or just the internet. People connecting to these virtual machines, whether they're computers or servers, will never even know they're virtual machines. There's no way for them to actually know that. Now, if you're just going to be connecting these machines to one another, there's no real need for you to use the actual physical network adapter on your computer. So you are going to be creating what we call network switches, or virtual switches to be more precise, all of which we're going to show you guys in a practical demo in a few moments. So within these virtual switches, you get three kinds. You get private, internal, and external. Depending on which one you choose, you are going to basically limit your virtual machine's capability. Private only allows them to communicate with one another. So if you have one or more virtual machines on your computer, they can only talk to one another. Data can only be transmitted between those two virtual machines on that host. If you've got an internal switch, they can communicate with one another and the host which they're being run on. And if you've got an external switch, that gives them full unrestricted access. They can communicate with one another, the host where they're being hosted, and anything else for that matter. External is the only real one where your data on that virtual machine is actually going to leave that physical host where they're being run on. So then you need an actual network adapter that's going to be shared. If you're going to be using private switches and internal switches, there's no real need for an actual adapter, not a physical one at least, because the traffic never actually physically leaves that physical host, if you think about it. So more on that in a moment. Some of the main functions of hypervisors is emulation. In other words, it's pretending to be something, pretending to be a virtual machine, pretending to have a network card, pretend, for lack of a better term. Guest operating system support, so that is the actual operating system on the virtual machine side. Assigning resources to each guest operating system. So when you create these virtual machines, you have the ability to go and choose how much resources they have, how much RAM you want to allocate, how big you want the hard drives to be, all that kinds of stuff. And once they have been created, even long after they've been running for a while, you still have the choice to go and change that hardware specs at any point in time. You can increase RAM, decrease RAM, and so on and so forth. You have the ability to go and configure networking. This can be done before or afterwards. And you can also go and configure security before or afterwards. All of that is nice. Okay, moving on to our next topic, type 2 hypervisor. Now, hypervisor I've been talking about up until now is Hyper-V, the one that comes with Windows. You're either going to go and turn it on as a feature if it's Windows 10, or in other words, if it's a client operating system, or if it's a server operating system, you're going to go and add as a role. Now, type 2 hypervisors is something you're going to go and install afterwards, like a normal program or like a normal software. That is, in other words, something that's not necessarily Windows. You get many other vendors or other programs. I mean, here they've got a few for you guys. They've got VMware, they've got Oracle, Parallels. There's actually a few that's not even mentioned there. You get VirtualBox. VirtualBox actually is there. Oracle's VirtualBox, Virtual PC, and all that. There's many kinds that's not actually listed there. So if you look at the picture on the right, you are going to still have your hardware. That's your physical computer that you can physically touch. You're still going to go and install an operating system, which is 10 to 1 going to be Windows 10. And then you will have a hypervisor of sorts. This could be the Windows hypervisor, or it could be this VirtualBox, VMware, or one of these other ones. So that is your type 2 hypervisor. Now on that hypervisor, whether it's Microsoft or not, you can go and choose what operating system you want to go and install. If you look at the picture there, you can see they've installed Windows 7, or it's an option. You can go and install Windows 7, Windows XP, Ubuntu, and, just to name a few. Obviously, we're not limited to just those. Those are purely just suggestions. So that is what type 2 hypervisor is. Now, getting back to those virtual networks we spoke of earlier. Multiple virtual machines can communicate with each other using standard networking protocols. As I've said before, a virtual machine is exactly like a real computer. It's simply virtual. So if you've got virtual machines, besides the fact that they use virtual switches, if you've got two virtual machines, the way they communicate with one another and the way they connect to real computers and other PCs outside and outside world is exactly the same that your computer would go and do it. They still go and use IP addresses. They still use the same networking protocols. Everything is still exactly the same. It just happens to be virtual now. That's the only difference. Now, the guest operating system emulates standard networking adapter hardware. Remember, it doesn't have its own network adapter. So it's going to pretend to have one. It's going to simulate one, for the lack of a better word. It's going to simulate as if it's got a network adapter, pretend, in other words. And it's going to basically BS your virtual machine into thinking it's got a real network adapter. Your virtual machine doesn't know it's a virtual machine. So your hypervisor, whatever hypervisor you're running, or hosting these virtual machines on, it is going to effectively go and BS your virtual machine into thinking it's got a real network adapter. Kind of like Pinocchio. I'm a real boy. It's going to think, it's going to pretend your virtual machine, or it's going to BS your virtual machine into thinking it's a real little virtual machine. I'm a real virtual machine. Yeah, you can see I'm sucking things out of my thumb today. Really on a roll. So you can often have multiple adapters on a virtual machine, exactly like a real computer. So on a real PC or a real server, we generally have one adapter. One card we can go plug a network cable into. And if you really want, you can go and put in a second adapter or even a third, and you can be connected to more than one network at the same time. Or you can go and use this to be connected to the same network of multiple cables in order to have some form of redundancy or load balance. The same can be achieved with a virtual computer. Now, hypervisor implements network connectivity via virtual switches. That's your pretend network cards. Functions like Ethernet switches. Implemented in the software, connectivity between virtual adapters and virtual switches configured in the hypervisor itself. So I'm going to show you guys that to the best of my ability in the demos that I'm going to give you guys. I'm going to be using Hyper-V today as my example, but the principle remains the same. Whether we use Hyper-V, VirtualBox, or whatever, the principle remains the same. If you can make a virtual machine on one platform, you can make it on another platform. The little wizards you go and create to create a little virtual machine, that might look slightly different, and the order in which they ask you stuff might be slightly different, but it's still going to ask you the exact same stuff and all of that. So if you can do one, you can do another one. So all of that's going to be towards the back of this video, or towards the end of this video, where I'm going to give you guys a demo on how to make a virtual machine, how and where to go and create a virtual switch, the different kinds of virtual switches you get, and when it comes to creating a virtual machine, what you need to be on the lookout for, and what questions you need to go and ask yourself, and what things you need to go and look and verify. Now, a little bit more on virtual machines themselves. Client and server operating systems can be virtualized. Doesn't matter what client or server operating system it is, they can all be virtualized. You just need the operating system in a virtual format these days. In the old days, you could go and install an operating system on a virtual machine via using either a physical DVD or CD if you had a CD, but it's probably going to be a DVD, or you can go and use what we call an ISO image. It's the exact same as a DVD, it's just basically in a digital format. And nowadays, if you go look at the newer virtual machines or newer hypervisors, they don't actually really support the old DVD ROMs anymore, a physical optical drive. That's kind of being phased out because if you go and buy yourself a computer these days, you'll find that most of them don't actually come with an optical drive anymore. Because why would you need one? We don't use that. So if you're going to go and use Hyper-V, for example, you'll find that now they give you an option to go and choose whether you want to go and create yourself a Generation 1 or a Generation 2 virtual machine. Generation 1 is the old legacy stuff that still gives you optical drives that you can go and use. Generation 2 doesn't have that option. You will need to, for example, use an ISO image if you want to go and install an operating system. Now, there's many purposes for deploying a virtual platform. You will have your own reason. There's pretty much not a company out there nowadays that doesn't run virtual machines. So the first time I started playing with virtual machines was around 2008, 2009. Some of my clients started using virtual machines. So obviously it's been out way longer than just 2008, but that was more or less when the shift started happening in my opinion, where some companies started tippy-toeing into the water, so to speak, with virtual machines. They would slowly but surely start switching the virtual machines over, or the computers or the physical servers over to virtual machines. And there was obviously a certain tipping point for cloud as well, which is an entirely different topic. We're still getting to that towards the end of the video. So I think that was around 2015, 2016, when companies started slowly moving towards the cloud as well. Now, with regards to client-side virtualization, as I've briefly said in the introduction of this video, client-side simply means we're going to be doing this on the client operating systems, on the end user's perspective. We're not going to be doing this on the server side. Traditionally, we used to only do this on the server side, and you would probably end up installing something like Hyper-V as a role, obviously. Nowadays, I would say half the time it's just going to be a feature you're going to go and add on Windows. If it's Hyper-V, you're going to go and install maybe some sort of software, and you're going to be running this on your local machine. Assuming you've got enough RAM and enough CPU and hard drive space. So if you want to run a virtual machine, you obviously need a pretty beefed up machine, a thick client, what we call it, which means you've got a lot of RAM, a lot of hard drive space, and a pretty beefed up CPU. If you don't have a lot of RAM and a lot of hard drive space and all those other things I've mentioned, it's not going to work because your PC is going to not have enough resources to run that virtual machine and sustain itself at the same time. Now, what is server-side virtualization? That's where we're coming from. That's what we used to go and do. Now, I would say that's only half the time. So in the beginning, it was only that. Now, it's a 50-50 kind of ratio. So if you are going to be doing it on a server side, it's probably going to be Hyper-V in most cases. Although VMware and those other vendors are also pretty popular in my opinion. Some of my clients had only Hyper-V in their environments. Some of my clients had only VMware in their environments. Some had a mix. So I think the one that was most common was a mix. You know, they had a mix. Some virtual machines would be Hyper-V, some would be VMware. Some things just work better on one platform, and some things just work better on the other platform. So depending on what their personal preference is, and depending on who recommended what, when, where, and why they recommended it, that'll probably be the deciding factor. So if I am the technician and I recommend to the client that, sir or ma'am, you need to go and use X, Y, or Z, they're going to take my word for it and they're going to end up using that. Even though it might not necessarily be the best option for their unique environment, they're going to take my word for it because how would they know? It's not like they would know if it's better or not because they don't know this stuff. I'm the IT expert, not them. So they're all probably going to be an expert in something else. This might be a doctor, a lawyer, or something like that. So they are an expert in their own respective field, and they're not going to question whatever I say, just like I'm not going to question whatever they say because I've got no cooking clue what they're talking about. Okay, so enough talking about mumbo jumbo and let's get to it. So I'm going to show you guys a demo on how you can go about creating a virtual machine, how you can go about creating virtual switches, and all the nitty-gritty stuff. So let's switch over to Hyper-V. All right, here we are on Hyper-V. Now you'll see there's already a virtual machine there. That is the virtual machine I actually used in the previous module, being module, what was it? Module 10, I believe. So in module 10, we were talking about server at some point, and that is the virtual machine we actually used within that module, believe it or not. So the first thing we want to go and do is show you guys how to go about creating a virtual machine. Now where we're going to go and do that is way here on the right hand side. There's the button that says new. And in case you guys haven't noticed, this is Hyper-V. So on Windows 10, you go and add this as a feature, as we've said earlier. On our server side, you simply just go and add this as a role. So I'm going to go click there where it says new virtual machine. Click next. Now here you need to go and specify what name you want to give this virtual machine. So that is basically where I typed in Windows Server 2019 of the previous virtual machine. So here you get to choose what you want to go and call this. So if I want, I can go and call this, for argument's sake, Windows 10. Now realistically in real life, especially if this is on a server that's hosting a lot of virtual machines, you're going to want to go and label this something proper. Don't just go and call it whatever you want, because if you have a lot of virtual machines, it can become a problem when you need to go and identify which is which. So if you come on this PC, let's say a few days later, a few months later, and you need to go and manage a certain machine, you're not going to know which is which. You're also going to make the next technician's life a living hell. So if you get to a server, imagine you're getting to a server and there's 10, maybe 100 virtual machines, and you are expected to go and configure something on one of them, or to go and troubleshoot or fix something on one of them. Now, how are you going to know which one to go and connect to if they're just labeled all over the place? So wouldn't it be nice if the previous technicians went and properly labeled those virtual machines? And that's what we're going to go and do here. It is a common courtesy amongst IT people to always label something properly. Always assume someone else is going to need to use this. Basically put yourself in that other person's shoes. What would you like to see? So for now, I'm just going to call it Windows 10. I suppose it doesn't matter what I call it since this is just a demonstration. Next, do you want to make a generation 1 or a generation 2 virtual machine? This is what I spoke of earlier. So if you're going to go choose generation 1, that is going to go and create the old legacy concept. Now, a few years back, there was no generation 1, generation 2 option. You would automatically go to the next menu, which is going to ask you how much RAM you want to go and allocate to your virtual machine. But at this point in time, you could possibly want to go and use generation 1 or generation 2. If this is your very first virtual machine, my suggestion would be to go for generation 2. It's still your choice near the day, but newer is usually better. Now, why do we still have generation 1 as an option, Venvo, if newer is better? It is because most companies are currently still running generation 1. They might have a lot of virtual machines. And for compatibility reasons and all kinds of other reasons, you're going to want to go and make any new virtual machine preferably the same generation. So if you've got 100 virtual machines that are generation 1, you're probably going to want to make the new virtual machine generation 1 as well. Otherwise, they're not going to get along very well. It's kind of like siblings that's going to be fighting amongst one another. Now, as for generation 1, you can see it still supports 32-bit. It gives you other legacy things like a BIOS. So if you know what a BIOS is. Where the new one doesn't have BIOS, it's got the new UV we spoke of. Generation 1, you can still go use the actual DVD or the actual optical drive on your physical computer to go and install an operating system. So if I've got a DVD for Windows 10, I can go put it in the actual optical drive of my computer and install it from the actual physical DVD. Generation 2 doesn't have that ability, because who still has the optical drive? Nobody does that. So for now, I'm just going to keep with generation 1 because realistically, that is the one we're still using most often. You're still going to use, if it's your first virtual machine, I would say go for generation 2. But if you have existing ones, you're probably going to end up using generation 1. So I'm going to go generation 1 for now. Next, how much RAM do you want to allocate to this virtual machine? So you're going to have to ask yourself a lot of questions here, and the same is going to apply to a hard drive. So with regards to memory, the first question you're going to go and ask yourself is, what am I about to install on this virtual machine? What operating system? So in this case, I'm going to pretend it's Windows 10. So first of all, what's the minimum RAM requirements for Windows 10? It's about 1 gig, but realistically, it's not really going to run until you go and put at least 2 gigs. 1 gig, you might be able to land on the desktop, and that's about it. It's going to be so darn gosh laggy, you're not going to be able to do anything. So let's say about 2 gigs, which is 2048 megabytes. So that's the minimum you're going to need. Now, the next question you need to ask yourself is, what am I going to be using this virtual machine for? So great, it's going to run Windows 10, but depending on what you're going to be using it for or utilizing it for, you might very well actually need more than 2 gigs. Maybe you need 3 gigs or 4 gigs. So let's say I've established that I actually need 4 gigs. So that's 4096 megabytes. Now the next question, so there's many questions. The next question is, do I actually have 4 gigs to give to this virtual machine? So how much RAM do I have on my physical host? So if I've got 32 gigs of RAM on my physical host, how much does the host operating system need? So in this case, I'm running Windows 10 on this host operating system. So as we've said, I need at least 2 gigs for the host. So if you take 32 gigs and you minus 2 gigs from that, that's about 30 gigs left. Maybe I need even more for the host, depending on what else is running on the host. So let's say I need 4 gigs for the host. So 32 minus 4 gives us 28 gigs left to play with. Minus another 4 for this virtual machine, that gives us 24 gigs left to play with. Now, you might think, okay, great, we've got more than enough RAM. Not necessarily. How many other virtual machines do you have? Do I have any? And if so, how many are there? How much RAM is allocated to them? And how many of them are running at a current point in time? Just because you've got a lot of virtual machines does not necessarily mean you need to be concerned, because it could be that a lot of them are turned off. Most virtual machines only use RAM if they're running. So if they're not running, they're not using RAM. Another thing you need to go and look out for is, are those virtual machines optimized for dynamic memory or fixed memory? Now, dynamic memory is this little checkbox we see here, which is actually ticked by default. So if I go type in 4 gig, which is what I did, I'm giving this virtual machine 4 gigs, but it's not necessarily going to go and use all of that. It's only going to take what it needs. So you might find sometimes during the day, it might be idling this virtual machine, just idling, doing nothing for the most part. And when that happens, you might find that it's actually just utilizing about 1.5 gigs, for argument's sake. Now, what's happening to all the other RAM that's just being not utilized, the other 2.5 gigs? It's just, well, cutting it off in most cases and wasting it. So if you're using this little tick box, in other words, dynamic memory, it's only going to take what it needs from that 4 gig. So if it's 1.5, it only takes 1.5 from the 4 gig, and the other 2.5 goes back to the host, and the host can go and utilize it however it sees fit. It can utilize it for itself, can allocate it to other virtual machines. So you've effectively got more RAM, to play with at the end of the day. So in most cases, you are going to want to run dynamic memory, especially if you've got more than one virtual machine. If it's just one, doesn't really matter. But if you've got more than one, you might want to go and tick that. If I untick the box, that is fixed memory. So it's going to give this virtual machine 4 gigs. As soon as I start the virtual machine, it chops off 4 gig from the real RAM. And it's only going to give it back once the virtual machine gets turned off. So for now, let's leave it on dynamic. Next, virtual switches. I'm going to skip this menu for now, because I actually want to go into here where we say virtual switch manager, where we need to go and set this up. So realistically, what's going to happen in this drop down list is you are going to go and choose one of your virtual switches that you've made, your virtual network cards, in other words. So as we said earlier, you get private, internal, and external. And when you go and make one, besides choosing between one of those 3 categories, you need to give it a name. The name doesn't really matter. So if it's an internal switch, Microsoft likes to go and call it internal switch, but in reality, you can go and give it the name of the network or whatever you want to go and do. So if you have a virtual switch, you can go and choose it. I don't have one yet, or at least I haven't showed you guys how to make one yet. Let's click on next. You can always go and change any of the stuff. You can go and change after the virtual machine has been made afterwards as well. So next, here we have the hard drive of this computer. So if you leave it on this one, which is the default, create a virtual hard drive. So you're going to go and create this virtual machine a brand spanking new hard drive. So you get, just like with the RAM, you're going to go and ask yourself a bunch of questions. What am I about to install? In this case, it's Windows 10. Now, if you're going to install Windows 10 32-bit, that is 16 gigs that it's going to occupy in a hard drive minimum. At least the last time I checked, it said 16 gigs. Please do not go and install 32-bit, because, my dear God, why would you want to go and do that? Now, if you're going to go and install 64-bit, which is what I recommend, it occupies 20 gigs. Big difference, right? Now, that is still, the last time I checked, it might be more. Keeping in mind, you still need to go and add drivers and updates and programs you need to go and install and data and all that. So you're probably going to need way more than 20 gigs. Minimum 20 gigs. I would say 35, 40 gigs minimum. And depending on what you're going to use it for, probably way more than 40 gigs. So I'm going to go and say 40 gigs. Now you're going to go and ask yourself, do I have 40 gigs or more of free space on my hard drive? So you're going to have to go and check on your computer. You're going to go to Explorer, check how much free space you've got. And if you've got more than that amount, well, then you're good. Now, what you could also go and do is you could go and say, use an existing virtual hard drive instead of making a new one. This is exactly the same as physically taking a hard drive out of one computer going to another computer and putting that hard drive in there. So I did not go and put a new blank hard drive in and install the operating system. I took an existing hard drive out of an existing PC and I went to another PC and I put that hard drive in there. Think of it as an organ transplant. Now that existing hard drive, which has got content on it, depending on what's on it, you might be able to boot from it. So if I took the main hard drive out of the other computer, in other words, the one that's got Windows installed or the operating system, you're going to put it in a new PC and you would actually be able to boot. The only thing you need to maybe go and do is just reinstall the drivers if the hardware is different, because it's got a different network card, different motherboard and all that. So you might want to go and install the drivers again, but other than that, it's going to boot. If it's a secondary drive, in other words, something that's just used for storage and all that, then you don't need to go and do anything. You just plug it in and there you go. You're going to have extra access to that data. So virtually speaking, the same thing applies. So when I go and say use existing virtual hard drive, I can go and take an existing virtual hard drive, just like you would do with the physical hard drive, and I can transplant it into this virtual machine, just like we could go and do with a physical machine. So instead of it being a physical hard drive, it's going to be a file that's VHD or VHDX, depending on whether it's generation 1 or generation 2. So alternatively, you can just go and say, you know what, I want to go and add a hard drive later. You can do that too. So for now, I'm going to say create a new hard drive. Next, how do you want to install the operating system on this virtual machine, whatever it might be? In my case, it's Windows 10. Do you want to do it later? So you can just go and say next and finish. Or do you want to go and say, you know what, I want to install this using the physical optical drive on this computer? That option falls away in generation 2. You do not have this option in generation 2. Or do I want to use an ISO image? You still have this option in generation 2. Very, very popular. If it's an ISO image, you can go and choose where this ISO image is. Alternatively, you can go use floppy disk. That also falls away in generation 2. Thank God for that. I don't know why you want to go and use that. And that is that. So I'm just going to say install later. I don't want to actually go and install it. That's not what this module is about. Click next. Finito. Give it a few seconds. And there we go. Our virtual machine has been created. Now that is the same as when you went and built yourself a brand new computer. You put a hard drive in it, which is blank, but you did not install an operating system yet. In other words, Windows 10. So that's a brand new computer with a hard drive in, but it's got no operating system on it. So you're going to have to start that PC up first. You can go and do it like that. That's one way. And the first thing it's going to do is it's going to look for a DVD, either physical or virtual, and it's going to try and install. It's going to look for something bootable. Now, the next thing I want to show you guys is the virtual switches. So I'm going to go here to my virtual switch manager. Now, I've got two here that's already been created. So if this is your first time coming in here, the only thing you're going to see is this option at the top. It says new network switch. You're going to see this part here that says global network settings and that little MAC address kind of thing there. You're not going to see these two. I went and made these ones afterwards. So if you want to go and make yourself a new one or your first one, you make sure you click on that option there. It says new virtual network switch. You choose what kind of switch this is. At any point in time, you can always go and change it afterwards. So private, it allows your virtual machines to only communicate amongst one another. So these two virtual machines at the back, if I go and put them on the same private switch, it doesn't help they're both on private, but it's not the same private switch. So if I put them on the same private switch, they can communicate amongst one another, but that's it. Think of it as lockdown restrictions. You know, with COVID-19, a lot of countries have been having lockdown restrictions, and I think they work from level 1 all the way to level 5 in most countries. Level 5 being the most severe, where you're not allowed to even leave your house unless you want to go to the doctor or buy groceries. At least that's generally how it works in most countries. So think of private as level 5, where you are not allowed to leave your house. It's very, very restrictive. Those virtual machines can only communicate amongst one another. That is it. Internal is a little bit more lenient. That might be like level 3 lockdown, you know, if you think about it. Internal, they can still communicate amongst one another, these two virtual machines. However, now they can also communicate with the host where they're being hosted on. So this host where I'm hosting them on can also communicate with the virtual machines and vice versa. External allows these virtual machines to talk to one another, the host, other physical hosts, virtual machines on other physical hosts, the internet. External is full-blown access. It's full-blown access. That's what it is. So private and internal, just different levels of authorization and all that, but they still don't actually leave the host. So internal, they can at least talk to the host where they're being hosted on, but the traffic does not actually leave the host. And if it doesn't actually leave the host, You do not need an actual physical network card since you never actually physically leave the host. So external is the only one technically that needs an actual physical network adapter, since it's the only one that actually physically allows traffic to leave that physical host. So for now, let's keep it simple. I'm going to say private, create. What do you want to call this? It doesn't matter. So I'm just going to call it private. Do I have one called private? No, I do not. Private switch. I don't know. Private switch, private network. I suppose I can call it private network. It doesn't really matter. Private network. And as you can see, at any point in time, you can change this. So private is private, internal is internal, but external allows you to choose your network adapter. If I choose external, generally speaking, on the average PC, in this drop-down list, you're only going to see one network adapter because you only have one, unless you've got physically more than one, or if you're using a laptop. I'm using a laptop today. So the reason if I'm using a laptop, you might see two, because the bottom one is your Ethernet adapter. That is the RJ45 port where you go plug in your network cable, your LAN cable, or your Ethernet cable. Now, there's so many ways you can go and call it. The top one is my wireless network adapter, the one that's physically built into my laptop. Most laptops have wireless capability, and most laptops have Ethernet capability. So I need to go and choose which one I want to go and use. If this was a normal average day-to-day desktop PC, you'll probably just find the bottom one. Now, me being on a laptop, I need to first ask myself, which one of these two do I use to connect to the internet at this exact moment? So today, I'm coincidentally using the one that's a Wi-Fi. If that's the one I'm using, I need to link that adapter to my external switch. And if I allocate that switch to my virtual machine, that virtual machine will have access to the outside world. It's like plugging a cable into that PC or connecting into a hotspot. That's what you're doing. If I were to go and choose the other one, Ethernet cable, and I link it to my virtual machine, theoretically it has access to the outside world, but it's as if the cable was never actually plugged in because it's on the wrong adapter. My laptop is connecting to the internet via the Wi-Fi, via the hotspot, and I've connected the virtual machine to my network cable port. So that's the wrong adapter that I've connected it to. So go and check, which one do you currently use to connect to the internet? If you're using a network cable to connect to the internet, that's the one you want to go and link to your external switch. So I'm going to go and choose that one there. Although, let's just keep this private for now. I'm going to say apply. Give it a sec. Okay. And now all that's left to do is to go right click on that virtual machine in question and go here to where it says settings. When you click on settings, that's as if you're opening the computer's box. So in real life, on a physical computer, if you were to go and physically open the box, what would you see inside? You would see the motherboard and all the hardware components. You would see the hard drives, if there are any, RAM, chips, CPU, all the hardware is what I'm saying. Now when I click on settings, that's technically kind of the same thing, digitally speaking. So if I click on settings, you can see the RAM, just like you would see if you would physically open the box. And when you open physically the box, you have the option to go increase RAM or decrease RAM. I can do the exact same thing now, just digitally speaking. If I want, I can go and add hardware, like a hard drive if I need to. I can add a network card and all that. So here I have the ability to go and add a network card, just like you would be able to do with a real computer. If I want, I can go and add extra hard drives, extra optical drives, you name it, exactly like a real computer. So with regard to that virtual switch we just made, at the moment if I go here to network adapter, it says not connected. And I can go and connect it. So if I go here, there's the one I made, private network. And if you click on that, that is like plugging a cable into your real computer in real life. So on your real laptop or desktop, when you plug a cable in, or when you connect it to a Wi-Fi hotspot, you're connecting it to a network. And when you click on that switch, that's the same thing. I'm connecting it to a cable or a hotspot. If I go to a different switch, that's the same as disconnecting from one Wi-Fi hotspot and connecting to a different one, which could technically be a different network. It could be the same, it could be a different one. It's probably a different one. Or it's the same as plugging one network cable out of your PC and plugging a different one in from a different network. Could be a different network, it could not be. So I'm going to choose that one there. At any point in time, you can go and change it, as you can see. And you do not need to turn the virtual machine off to be able to change that, just like a real computer. Do you need to turn your real computer off if you want to disconnect from a hotspot or plug a cable out? No, you do not. You can just plug the network cable out and plug another one in. You can just disconnect from the hotspot and connect to another one. The same applies to a virtual machine. Now in real life, if you want to go and physically take a hard drive out or change the RAM on a physical computer, you normally need to turn that machine off. The same applies to these virtual machines. Although depending on how new your Windows 10 is or how new your server is, RAM is actually hot swappable nowadays. So while the virtual machine is running, you can actually increase or decrease the RAM, but it depends on how new your Windows 10 is, what build you've got and what update you've got. So that is a function that came out on Server 2016, and I've seen they've incorporated in Windows 10 as well. So if I want, I can go and add more network adapters. I can go and add hardware. You can see I've got more, so I can be on more than one network at the same time. If I want, I can go here to the IDE controllers, and I can go and add more optical drives, like a DVD drive or hard drive. So if I want another DVD drive, I can go and add one. Here we go. Got another DVD drive. So that, my friends, is what virtualization is. So at this point in time, we've showed you guys what a virtual machine is. We've used Hyper-V as the hypervisor example, but technically the same principle applies to the other vendors. If you were using VirtualBox, VMware, all that, same principle. The menus might just look slightly different. So when you go here to new in virtual machine, the wizard might just be slightly different, but it's going to ask you for the same things. Still going to ask you for a name at some point. It's still going to ask you for RAM and hard drive and all that at some point, just in a different order perhaps, and the menu is going to look slightly different, but it's going to be the exact same principle. So that's what virtualization is, more specifically what virtual machines is. Now there's something else you guys need to know. You don't just get virtual machines, you get virtual containers. Now the name tends to confuse people. So we've just talked about virtual machines, and a virtual machine has its own operating system. So if you look at the left-hand picture there, that is an example of a virtual machine. You've got a computer, which is a server most likely. It could be Windows 10. So if you look at the way bottom block on the left, it says server. Could be Windows 10 in my case. Then you're going to go and install your operating system. And that's probably going to be Windows 10 or server. Then you're going to be running your hypervisor software. It could either be Hyper-V or Type 2 in that picture. And on each virtual machine will have its own respective operating system. You get to choose what that operating system is. Does not need to be Windows necessarily. And on each operating system, it will have its own little registry, its own unique applications and all that. Now on the right hand side, we've got containers. Now with containers, they look very much the same as virtual machines. When you connect to them, they're going to seem very much the same as virtual machines, but there's some very distinct differences between them. So you can see on the right, you still have your physical server or computer. You're still going to go and install your actual operating system on the computer. So it's still going to be server or Windows 10. That's going to be exactly the same. But instead now, you're not going to be using some sort of hypervisor software. You're going to be using something called Docker. Docker is actually not a Windows thing. It actually is a Linux tool, but Microsoft has now incorporated it into its software. Now, each container, which is going to look and behave exactly like a virtual machine, does not have its own operating system. Virtual machines, each of those has its own operating system. Containers, if I've got 3 containers, it's going to look like 3 virtual machines, but it's not. They do not each have their own operating system. They share the operating system of the host. So whatever operating system your host PC, the physical PC, is running, that is what your containers will be running. So if my host is running Server 2016 or Server 2019, that is what you're going to see on your containers. So there's pros and cons. Both virtual machines and containers have got lots of pros and cons. With virtual machines, if each virtual machine has its own operating system, that is going to occupy a tremendous amount of space, especially if you start looking at 10 or 100 virtual machines. That is a huge chunk of space just for storing the operating systems. Now, if each container, if you've got 10 or 100 containers even, you do not need to go and make space for the operating systems because, well, you only need one. They're all sharing the operating system with your host. Now, with that said, no, you are not going to find all your host files on those containers. That is confidential. So only the host operating system and the host files, the host operating system files, are shared between the containers. So if you've got all kinds of documents and files and personal stuff on the host operating system, if you were to go to the container, the only thing you would see is a blank desktop. It's kind of like a fresh copy of Windows that was just installed. There's no programs on it. There's no documents on it. It's like a blank, fresh copy of Windows. It's only sharing the operating system files, not your documents and personal files, anything like that. So that's a benefit. The benefit is we're saving space when it comes to your operating systems. A con here would be, a downside would be you do not get to choose the operating system. That's a downside. So on virtual machines, you could at least choose your operating system. Containers, you're stuck with whatever the host has. So if the host is running something that you don't want on a container, well, guess what? You're stuck with it. You are saving at least on space. Now, virtual machines, how long do those puppies take to start up? Pretty much exactly the same as a real computer. If you go and press the power button on your real physical computer, how long does it start? Let's say for argument's sake it's 30 seconds. Your virtual machine might take 30 seconds then. A container, how long do they take to start? It's pretty much instantaneous. Because remember, we're sharing the operating system with the host. It's near instantaneous. So that's pretty much the difference. A container is very much the same as a virtual machine, but it saves you on space. But you don't get to choose the operating system, and you don't use hypervisors of some kind. You use something called Docker, where virtual machines use something called a hypervisor, which could be Hyper-V, that's Microsoft's version of a hypervisor, or it could be some form of third-party software like VirtualBox, Oracle's VirtualBox, or anything like that, VMware. There's lots of ones you can go and choose. Okay, so I think that's pretty much enough for virtualization for this module. So let's take a look at cloud computing. Now, first of all, what is the cloud? The cloud is basically, in a nutshell, when you go and put something somewhere else on someone else's property. That's all it actually is. So if you've got something like data on your computer, your laptop, your desktop, or your company server even, it's just that. It's just data. If you have, for example, a software, an application of some kind that's installed on your laptop, your desktop, your server, it's just that. It's just software. And the list just goes on. If you've got a virtual machine, for example, that's running on your machine or your company server, it's just a virtual machine. Now, all of those things I've mentioned and way more, whenever you go and take that stuff and you put it on someone else's property, let's say Microsoft, for example, and this could be an example, maybe, for example, a platform like Azure or Azure, depending on how you want to pronounce it. If you go take that platform and you go and upload that content there, or you host it there for that matter, what is that? That is the cloud. So they are rendering that stuff back to you as a service for a monthly fee. So that data, which would normally be on your computer, if it's now somewhere else, like on OneDrive, Dropbox, Google Drive, Box, File Share, Citrix, there's a lot of places. So if you go and put that data of yours and you store it somewhere else, what is that? That's a form of cloud, friends. So if you go and put it somewhere else on someone else's property and they're rendering it back to you as a service, that's cloud. Now, if you have something like a program, an application that would normally be running on your computer or your company server, and you're running it somewhere else, and you're just basically accessing it via something like a web browser, what do we call that? It's a form of cloud, more specifically software as a service. If you have something like a virtual machine that would normally be running on your computer or your server for that matter, that is an example of infrastructure. If you take that virtual machine and you go and upload it into the cloud, or let's say you're going to upload it to Azure. You upload it to Azure or AWS, or you go and create it from scratch on Azure or AWS. What is that? It's an example of infrastructure as a service, which is also a form of cloud. So someone, AWS or Azure perhaps, are now hosting that virtual machine for you, and they will charge you most likely like a monthly fee. Sometimes it's a yearly fee, but it's usually like a monthly fee. So you can just go and access that resource of yours now via the internet. Now this someone else we're talking about, which might be Microsoft or Amazon. Amazon is AWS in case you guys don't know. That someone could literally be anywhere. They could be right next door. They could be across the street. They can be in a different town. They could be in a different country. They could be on the other side of the globe. It doesn't matter where they are if you think about it. The fact that it's on someone else's property and that they're rendering that service back to you for a monthly fee over something like the internet, that is what is cloud. Now, with regard to cloud, there's many benefits and many things we can talk about, but this is not a cloud course. We're simply just talking about cloud as a topic in general. So you have on-demand self-service, and you've got broad network access, resource pooling, rapid elasticity, measured service, just to name a few. So what's going to happen here is whenever you go and host something in a cloud, it's hosted on a server where you're sharing resources with other folks in the world. So if I have a virtual machine, for example, instead of it running on my laptop, it's running on a server in Microsoft or Amazon server in the server room. And on that very same server, there's virtual machines running from other companies across the globe. The concern people here have is, what about security? Since I'm sharing this server with other people in the world, can they access my stuff? Can I access their stuff? Absolutely not. Security is not of concern. So the concept of you sharing that machine, those resources of other people, is called resource pooling. And if you've got something in the cloud, you can access it from anywhere in the world. Broad network access. So people can join something like a Azure domain. You can access it from anywhere in the world. You can go and upload stuff from anywhere in the world, download stuff from anywhere in the world. I mean, that is the future after all. Virtual and cloud is the future. You've got immediate access to pretty much anything that you want. You can increase something, decrease something, change something at will with a fraction of a second's notice. Where on premises, sometimes it's possible to change something, but it's going to cost you an arm and a leg, and it's going to take you days, weeks, or months to get the job done. Now, that brings us to the second last bullet point we've got there. I have the ability to very quickly go and scale up, scale out, or scale back in or back down, or just change something in general very quickly. So let's give you an example. I want to go and increase the resources for my virtual machine. Maybe I want to go and increase the RAM. Now on premises, if you want to go and increase the RAM for a server, it's not that it can't be done. It's just it's going to take time. You're going to have to go and plan for downtime. You're going to have to make sure you actually have a RAM chip to put in there. You might not. You're going to have to go and order one perhaps. That could take hours or days or weeks even. And you're going to have to turn the server off eventually. Then you're going to have to bring it back up. And generally when you bring it back up, there's always something wrong. Now in the cloud, you can increase something like the RAM almost immediately. It takes a matter of a few seconds and you can go and increase the RAM. If you don't need it, you can always decrease the RAM. If you need additional servers in the cloud, you can go and scale out. Scaling up is increasing the resources on your existing servers. So like in other words, adding more RAM, more hard drive space, that's scaling up. Scaling out, vertically or horizontally, I should say, horizontally, that is when you go and dropping additional servers, basically clones. So scaling up, which is vertically scaling up, is just improving on your existing servers. You're just boosting them, giving them a bump, in resources. Horizontal scaling, or scaling out as they call it, is when you're dumping more servers. That's basically clones, so you can handle more load. That is horizontal scaling, or scaling out as some people call it. Now it's still possible on premises, but this is going to cost you an arm and a leg. It's going to take forever and a day. And if it's in the cloud, it can be done in a matter of about a minute or two. Really is that quick. Now, earlier I mentioned that you can also scale back down. In other words, reduce RAM and remove some of these servers. You're probably wondering to yourself, but why would you want to do that? Normally on premises, if you increase the RAM or the servers, you can't think of any reason why you'd want to go and decrease it because more is usually better. Well, another benefit of the cloud is you only pay for what you use. That brings us to the measured service. If you don't use something, you don't pay for it. So if I've got 3 virtual machines in the cloud and I turn 2 of them off and they're not running, I'm not paying for them. So they've got a per minute billing system in most cases. You get charged by the minute, but even though it's put by the minute, it still works out way cheaper than buying your own servers and running them on premises. In most cases it does. So if I don't go and run those virtual machines, I don't pay for those virtual machines. As long as they're off, I'm not paying anything. And this applies to a lot of components in the cloud. There are some things in the cloud you just can't go and turn off, and there's some things you can go and turn off, like a virtual machine. So if you don't run it, you don't pay for it. Alright, so here we just have more of what we just said. Rapid elasticity, the ability to scale cloud computing resources quickly to meet peak demand, and just as quickly remove resources if they are not currently needed. So if I don't need it, you're going to go and remove it because then you don't pay for it. And if I see I've got an unexpected spike in traffic, whether it's a website I'm hosting or anything else for that matter, you can very quickly increase those resources as needed. Where on premises, you might see that you need more, but it's going to take you a few days or weeks to get the job done. As for measured service, a provider's ability to control and bill a customer's use of resources such as CPU, memory, disk, and network bandwidth through metering. You only pay for what you use. So the more CPU power you add to a virtual machine, the more you're going to pay for it. The more memory you add to that machine, the more you're going to pay for it. If I see I need a virtual machine in the cloud, but I see it doesn't need to be really fast, I can get away with just 2 gigs of RAM instead of 8 gigs of RAM, well then do so. Reduce the RAM. If you reduce the RAM, it might run at the same speed for you, and if you don't run with more RAM, you're going to be paying a lot less. So why the heck not? Now, something else we can talk about is cloud service options. You get something called SaaS, which stands for Software as a Service. You get Infrastructure as a Service, and you get Platform Service. Those are the 3 we've got. Now, those are all 3 a form of public cloud. So you get private cloud, hybrid cloud, and public cloud. Not something you guys need to know at this point in time. Public cloud is whenever you put something in the public sector. It's running completely on someone else's property, someone else's data center like Microsoft or Amazon, and that's that. So it's completely somewhere else. Hybrid is when it's partially running on premises and partially on someone else's property, where private means it's your own data center, your own infrastructure, but it's still a form of cloud. I don't know. I've got a lot of debating about private cloud. I mean, is it really private cloud if it's still your own data centers? It is, but it is not. So all three, the ones we see there, those three are all three public cloud. There's actually other ones as well, but those are the three main ones. So software as a service is when you would normally have software installed on your computer or your desktop, but instead of it being on your desktop or your laptop now, it's running somewhere else, it's installed somewhere else, and it's simply just displaying onto your screen. Your screen could be a laptop, desktop, tablet, phone, it does not matter. It does not matter how old your device is, how slow your device is, how cheap your device is. As long as you've got a screen and an internet connection, you can run that program. So maybe your device only has 1 gig of RAM, 1 gig of RAM, and this program in question maybe needs 2 gigs or 4 gigs of RAM to be able to run. Guess what? It doesn't matter because it's using RAM somewhere else. It's installed somewhere else. It's running somewhere else. It's using Microsoft or Amazon or whoever's RAM, whoever this cloud provider is, it's using their RAM. It's not using yours. So it doesn't matter what your resources is, as long as you've got an internet connection, you can run that program over the internet, most often via something like a web browser. Now, infrastructure as a service, which is the middle one there, let's first establish what is infrastructure. That is something like a virtual machine. So if I have a virtual machine on my laptop, desktop, or my server, that is seen just as infrastructure. If you take that virtual machine and you go and upload it to a cloud platform like Amazon or Azure, or you go and create it from scratch on Amazon or Azure, what do we call it? That is infrastructure as a service. That virtual machine is now being rendered back to me as a service, which was infrastructure originally, but now it's being rendered back as a service. So it's infrastructure as a service. The last one is the trickiest one to explain, which is platform as a service. So examples of this will probably be your Azure Active Directory. So if you were to go on to the Azure portal, for those of you that's ever seen the Azure portal, one of the many benefits you get on the Azure portal, which is one of Microsoft's biggest cloud platforms, is Azure Active Directory. Now, normally you would have Active Directory just on premises. You would have a server. You would go and add the ADDS role, Active Directory Domain Services, which effectively installs the Active Directory software, but it is for the most part limited to on premises, which means you need to be in the same building in most cases to be able to use those user accounts and those groups and stuff. Now, if you want to go and put it on the Azure platform, you can go and use something called Azure Active Directory. Now, the benefit there is you do not need to go and install a physical server. You don't need to go and build a server. You do not need to go and install the server operating system. You do not need to go and add the Active Directory role. Nothing. You can pretty much just jump in, create your user accounts, create your groups. At the very most, you're going to maybe just go and link your domain. That's it. There's very little that you're going to be doing from your side. That is platform as a service. That's pretty much when this vendor, which is maybe Microsoft or Amazon, when they do all the heavy lifting for you, and you just kind of swoop in at the last minute and just reap the benefits. You can think of this as going into a grocery store, and when you go into the grocery store, you go and buy yourself a bag of frozen veggies. These days, they're all pre-mixed and pre-sliced and pre-diced, and all you need to go and do is just buy it, take it home, throw it in a pot, maybe with some water or something, and there you go. Most of the work has been done for you. You just kind of reap the benefits at the last moment. You can also think this of this as going into a grocery store and buying one of those pre-made meals. Some grocery stores you might be lucky enough to find one of those pre-made meals, like a lasagna or something, and all you need to go and do is just take it home, pop that sucker in a microwave or an oven for about 10, 20, 30 minutes, and there you go. You can even tell your family and friends that you made it, meanwhile you just bought it and you just kind of heat it up. I know a lot of people that actually does that, mind you. So that is once again an example of platform as a service. You're swooping in at the last minute, reaping all the benefits, claiming it as your own. Meanwhile, in reality, you only did like 10 or 20% of the work. That is platform as a service. The other forms of cloud we get is cloud-based applications. It's not the only kinds of cloud we get. I mean, we can talk about this all day, but we're trying to keep this simple. We're trying to keep this within A plus, and we're trying to keep it to the exam objectives. So you get something called application virtualization and something called virtual application streaming. Now, as for application virtualization, rather than running the whole client desktop as a virtual platform, the client either accesses a particular application hosted on a server or streams the application from the server to the client for local processing. So an example of this will probably be something like remote app. It's very similar to software as a service. Something like remote app means it's installed on a server. It could actually be on your own server in this case, mind you. So it could be your server, it could be somewhere else. You're streaming it to your device. The downside is if your internet connection drops, the program doesn't work. You generally need a very fast and very stable internet connection, otherwise it doesn't work. The pros is it doesn't matter how slow your PC is and how little your resources is, you can run pretty much any program as long as you've got a stable internet connection. Now, virtual application streaming is very much the same as something called AppV, application virtualization. So you still need an internet connection, but it doesn't need to be fast. It doesn't need to be stable because this application is partially actually installed in your computer. So unlike the previous one where you could run the cheapest and the lowest spec PC that you want to go and run, here you do need a little bit of specs because you are going to partially run it on your PC. It's going to somewhat stream, but it's not. Some of it's going to be on your PC, some of it's not. So yeah, which one you're ultimately going to go and use depends on your internet in your environment. So if you've got an internet connection that's very unstable, intermittent as they say, then you might want to go for the second option. If you have a stable internet connection but you've got PCs that's very cheap, very low spec, then maybe you're going to go for the top option. So at the end of the day, they're just trying to give you maximum flexibility and maximum choice. So it's nice to have choice. I mean, it's the same as going into a grocery store and you have a choice between cool drinks and cookies and chips. The more choice you have, the better. Alright guys, so that pretty much concludes it for virtualization and cloud, and that pretty much concludes it for module 11. So all that's left to do is to give this video a like. So if you feel like you've learned something or if you've enjoyed it, please give the video a like. Like I've said before, it does help this video. It does help my channel when you guys do that. It basically boosts my channel and it promotes me. And if you feel like it, maybe drop a comment down below. So never mind if you're struggling with a certain topic or something, if you go and drop comments down below, that actually also boosts my channel when you guys go and do that. And then for those of you that's just new in the channel, or if you would like to know when I release something new, feel free to go and click that subscribe button, preferably with the notification bell. And if you guys really do struggle with something, I mean, you always can really go and drop a comment down below and just let me know what you're struggling with, and I will gladly assist you guys. Alright guys, I will see you on module 12.
If you love me, let me know. If you don't, then let me.